Thanks, Grace. Yes, I highly recommend skydiving if you haven't done it before. It is awesome. So as Grace mentioned, I'm a senior developer and I'm on the purchasing team. And today I'm going to talk to you about mock servers and how you can fake all the things. Quick overview of the agenda. I'm going to tell you about the problem we had, how we fixed it by mocking all the things, why you should use mock servers, how to create them, and finally, things to look out for when you use mock servers. So firstly, the problem. A couple of years ago, the team that I was working in, we were working on the billing overview inside your site administration. Basically, improving the bill, the UI, the UX, and the feel of it. Making sure it was easy to understand, adding and removing your credit card, everything related to your bill. However, the problem we had is we were generally seeing a page that looked more like this. A red error message, something had gone wrong, and we couldn't really work on improving the billing experience. As you can imagine, this made us really frustrated. We just wanted to develop, but we couldn't. So why did we have this problem? Well, we had our code base, and like most systems currently, you don't talk to just yourself, you talk to other systems. You have external dependencies that you need to rely on. For us, we had authentication systems, we had payment gateways, we had accounts databases. So we had a lot of different systems that we depended on. And these systems were extremely complicated, which meant it wasn't feasible for us to bring it up in our local environment. Some of you may have this similar experience, and it's frustrating. So we thought, okay, let's talk to these teams and see what we can do. They were very helpful, and they said, we have dev environments for you. You can point to our dev environment. We develop against them. It should work for you, because it's sort of like pointing to production, but it's a dev environment. Seemed like a good idea, except dev environments are dev environments, and things go wrong. Sometimes you get a weird response, and we talk to the team, and they tell us, oh, we're sorry, we did a bad merge to master. We'll fix that in an hour or two. Unfortunately, in this hour or two, we still see the red error message. Other times, we just simply don't get a response at all. We talk to the team, and they tell us, no, our server looks fine, everything's good. Oh, actually, it's the service that we depend on. They've fallen over, so they're not responding to us, so we can't respond to you. As you can imagine, this is extremely frustrating, because you're fighting with your environment rather than actually developing. So what we really wanted was to sort of depend on these services, but not really. We needed the information they were giving us. We needed to do the interaction with them, but we didn't want the extra baggage of having to deal with their uptime and them being correct. So we decided to fake all the things. We decided to create mock servers and pretend that these servers weren't really there, and instead there would be fake versions of these servers. And that is effectively what a mock server is. A simple service that provides dummy data to mock or simulate external dependencies. So why should you use mock servers? Apart from being able to develop and instead of frustratingly trying to get your environment up and working, there are many other reasons you should use mock servers. So this diagram that I had earlier is sort of true, but not really, because when you use mock servers, really what happens is your code for your mock server is inside your own repository. So it is isolated within your own code base. Now, because of this, there are many benefits. The first one is isolation. You have everything inside your code base, so everything is self-contained. Everything is decoupled from your external dependencies, so it doesn't matter if the team that you depend on accidentally did a bad push to master. It doesn't matter if they've down because they have memory leakage. You are decoupled from your external dependencies. And because of this, you have a very stable environment you can work with. A second benefit with mock servers is you have faster dev loop. The reason with faster dev loop is simply because you're talking to localhost. You are no longer pinging a server halfway across the world. You're pinging your local machine. And this means you can really quickly iterate and improve on your user experience. Of course, performance is something that you want to work on, and performance is something you should look into, but it is not something that you want to be looking into every time you refresh the page just to check if the CSS is correct. It is something that you want to look into specifically. And finally, last but not least, mock servers gives you the benefits of better testing. When I mention mocks or mock servers to people, they immediately think testing. And this is probably because in unit tests, we use a lot of mocks. We use JMock, Mockito, etc. And there is no difference here with mock servers. And it is powerful because you have full control over what your mocks are giving you. You have the ability to write anything you want, so you can create those edge cases that are incredibly hard to replicate. And in mock servers, it is actually incredibly easy to do this because you have the control. Unlike unit tests, though, mock servers gives you the ability to write end-to-end tests. You can actually have your code talk to the external service, in this time your mock service, make that HTTP call, get the response back, and then that way you have your end-to-end tests. And with all the various edge cases that you can come up with, your QA engineer will be extremely happy. So these are great benefits. And the next question then is, how do you create your mock servers? Well, there are two main ways you can do so. The first is to use a third-party library, and the second is to build your own. There are many third-party libraries out there. There's WireMock, Mock Server, which is very aptly named, and a lot others. You simply Google it, and you can find out a lot of them that may or may not suit your needs. All of these external libraries have a great benefit in that they're really feature-rich. They have a lot of things that you can use. They have these scenarios that you can use to write your test cases against. You can simulate latency if that is something that you need. You can respond based on a particular request type. They're extremely powerful and rich. Despite this, though, we actually went down the build your own path. And that is because we really basically just wanted something simple and easy. We were frustrated with our dev environment, and we just wanted something working. And so we weren't really in the mindset to be reading documentation and trying to figure out how to work a library into our existing system. Our existing system was something that was simple. It was a simple Node.js app. So when we decided to build our own, we thought an Express server is the best way. It makes the most sense. Now, when I say that our initial mock server was simple, I really do mean simple. It was a grand total of 36 lines of code. This included white lines, comments, everything. So as you can see, this mock server basically was probably the simplest thing you could write. And it effectively handled two routes. The first route handled a post request to a particular URL that matched this pattern. And if you hit this, it would just return you a 202 accepted. Everything was good. It didn't really care what happened. It just made sure it returned a response. The second request that it handled, the second route that it handled is a bit more complicated. And that's because this actually handled every other API that we depended on for our billing UI. And this one, basically any request that matches this URL will fall into this particular route handler. So if you made a GET request to the instance pricing URL, it would fall into this handler, and three things would happen. Firstly, we would lowercase the method. Then based on the URL, we would rearrange it a bit in order to get a file path. Once we have the path to a file on the file system, we would get this file from the file system and return it as a response. So extremely simple. Based on your URL, we go and grab a file off the file system and return the response. In the file system, we have a lot of JSON files, and this is sort of where the magic happens. Based on the JSON file name, we can easily mock out all the different APIs that we needed. In this case, the pricing get.json simply has a JSON blob inside it, which means that when you hit the GET request for instance pricing, the mock server looks at the URL, looks at your method name, rearranges it, looks into the file system, and returns this JSON blob. Similarly, we were able to replicate the other REST requests in the same fashion. So this red error message was no more. We now had a stable environment in an isolated way that we could develop against, and everything was awesome. We were happy, we were developing, we were no longer fighting with our environment. Until we realized that we had a bug, so everything wasn't so great. So, quick question, can you see which REST request is different from the others? Yep, the post. So the post requests are different from GET requests because they generally have an extra bit of data that you send, and that is the post data. The problem that we had was we were sending an incorrect payload with our post data, but our mock server was being too simple, being too helpful, and it still returned a response. So when we actually talked to the real server, it freaked out and gave us an error. In order to fix this, we added an extra JSON file, the post data JSON. Within this file, it had the JSON data blob that we expected as part of the post data payload. And of course, we had to then modify our mock server. So instead of handling everything in an app.all, we now had to split the post and the get. And in the post, we had added an extra step of validating the post data. And only if this passed, would we resend out the JSON response and therefore give you the response that you expected. So everything was actually awesome now. We were actually able to develop easily, quickly, in a stable environment, and we were sending the correct post data. The next step for us was adding scenarios, because as I mentioned earlier, we wanted the ability to integrate this into our tests. And manually modifying your JSON response in order to get your different scenarios was very tedious. So to introduce scenarios, we introduced state to our mock server. As you can see here, there are a wide variety of states that we could mock out. Happy parts, sad parts, anything that you can think of. Within each of these states are the relevant JSON files that have the JSON blobs that you expect for the state. In order to change the state for our mock server, we added a dedicated URL for it, and it works quite simply by just hitting the get request /state/ whatever state you want. In this case, it's all the products. So this would set app.state to all the products. And what happens is when we actually get the JSON file, we would look into the app.state, and if it exists, we'd look within the states directory and underneath that directory in order to find the relevant JSON file. So in this case, all the products, inside there is the relevant JSON files to simulate all the products. So instead of always developing against this one single state, we were able to easily switch between different states. In this case, all the products, and also we could do transient states, like Jira activating. You can probably imagine if we were talking to a real service, this would be extremely hard to replicate. We'd have to start up an instance, Jira activating would probably exist for a couple of minutes, and then Jira would be up, and Jira activating state would be gone. But with mock servers, we could easily keep this state frozen at Jira activating until we wanted to change it to something else, like say an error message. So in this case, we simulated an error in the payment gateway. You have a valid credit card, hasn't expired, but for whatever reason, there's an error. Something that's extremely hard to replicate, even in dev, can be easily replicated in the mock server land. So I have to admit, with all these extra improvements, our mock server was no longer simple. It's about 442 lines of code now, and it is a bit of a pain to work with it. It requires maintenance overhead. You need to understand what's happening. You need to poke around a bit in order to add new states. It's not as simple as it was when we first started. Despite this, though, we felt that handling the mock server was still a lot better than trying to deal with the environment issues that we had earlier. So when we moved to our next project, we decided to duplicate this idea. We also decided to write a second mock server for our new project. This second mock server, however, had two key differences. The first one is we no longer had state. We stepped away from having state because state generally complicates things. Instead, we decided on which scenario to pick based on the unique identifier, either in the URL or in the headers. So if we wanted the Jira activating state, we would name it appropriately and have the file system, in the file system under Jira activating. And the second key difference is we had what I call smarter JSON. Instead of simply returning a JSON blob, we would return an array of interactions. This was extremely powerful for post requests because it meant we could do request response pairs. So if you send in a request that had a post request that had Jira.onDemand as a single product key, we would respond with a particular response. In this case, 3 product keys all related to Jira.onDemand. You can also define your second interaction. In this case, if you also did a post request, but this time you only had Jira Software.onDemand, we would then reply with a different response. We would respond with a 200 OK, but it would be a single product key. As you can imagine, you can add as many of these type of interactions as you want. It could be an error state. If you send in with an empty array, maybe it would respond with an error. So at this point, we felt like we had succeeded. It was great. Our mock servers were working. We were able to simulate different scenarios. We were able to respond accordingly based on the post payload. Everything was working great. However, not everything in this world comes for free without strings attached. And unfortunately, mock servers are one of them. So there are things to look out for when you use mock servers. I have alluded to it earlier, and that is that mock servers can be quite complicated. They may start off easy, but the more powerful you make it, the more complicated they get. And this means sometimes they will act weirdly. They won't always behave the way you expect. And this requires time and investment into refactoring it a bit, making it simpler, onboarding new team members to make sure they understand how the mock server works so they can write tests and they can develop. However, the most important thing with mock servers is probably making sure that your mocks are up to date and accurate, and that they are mocking reality. And what do I mean by this? So you have your code base, and as I mentioned earlier, you realize that you depend on this external service, but it is way too complicated to keep this external service in your local environment, and the dev environment isn't stable. So you create a mock server. Your mock server is going to replicate the response from this external service, which is great, because that is what you expect. However, as time passes, your external service may change the way they respond to you. But during this time, you're unaware of this change. So you're developing against your mock server, and your code starts to handle this particular response. It knows how to handle this. It has a particular shape. It expects this response. So when you deploy it to production, or staging, hopefully, the external server has a different response. And then when it reaches your code, you don't know what will happen. The best case scenario is that the modification didn't matter. It was insignificant. They added an extra field that you don't care about, so your code happily goes on and everything is good. But as developers, we know that this never happens. It is always the worst case scenario that happens, and the worst case scenario can be that the change is subtle. So your code still handles it, but it only works 80% of the time. And there is 20% of the time where it dies and has a subtle bug. And this means that it could slip through QA, slip through your tests, and get into production. So what you really want to do is make sure that when this response reaches your code, you are warned that you know it's different. And in order to do this, you need to compare them. You need to compare your mock server and your real server. The best way to compare these two different pieces of JSON is to use JSON schemas. Now, there is a JSON schema definition language at jasonschema.org, and it is extremely powerful. It lets you define exactly what you want and what you expect in your JSON file. So here is a quick example of a JSON schema file that we expect. So you can see, in this particular example, we expect that the response is an object. And this object must have 5 fields. Must have host name, current billing period, next billing period, active products, deactivated products. It can have more than these 5 fields, but if any one of these 5 fields are missing, the JSON schema check will fail. And on top of this, these 5 fields must satisfy the following properties. The host name must be a string. So if you do have the host name field, but you put in an array, it is going to fail as well. Current and next billing period must be billing period definitions. These are custom definitions that you define in the same schema file. Similarly, active products and deactivated products, they must be an array, and the array must contain product elements. So these custom definitions are very similar to use the same JSON schema language. Your billing period must be an object. And again, it must have these three fields: renewal frequency, start date, end date. And you can specify exactly what these fields are. As you can see, you can really easily and concisely define exactly what you want in your JSON file. And so once you have your schema definition, you can then compare your mock server and your real server. As you run your tests, most of the time, or hopefully, it will always pass. But there are some times when it will fail. Now, when it fails, this is the time when you need to look into it and understand why has it failed. It could be that they added an extra field or they removed a field that you don't care about. And one thing to note is your JSON schema file may be too strict, and this is a time to update your JSON schema file. It could be that the external team have accidentally changed and broken the contract, and this is a time to talk to them to understand why did this change happen, should it be reverted, or is this something or has the contract been updated now and you have to change your own code? A great thing is that this JSON schema definition, because it is a standard, making these comparisons is really easy because there are a lot of libraries out there that will help you make these comparisons. Some of you may be thinking, but if I want to talk to the real server to make a comparison, then I have to talk to the real server, and I am now susceptible to the real server being down or having bad code. And yes, this is one sort of weakness of this particular JSON schema check, but instead of having to depend on the real server every time you're trying to develop, you've now pushed it right to the edge, and you're depending on the real servers only when you push to master or only when you push to a remote branch. And on top of this, you can put these schema definition checks into your continuous integration. You can add them into a scheduled build so that it will build every night or every day, depending on what you need. And this is great because sooner or later, you're going to be finished with the project you're working on currently, and you move on to your next project. So you're not concentrating on your existing project. And as your scheduled build continues building, usually it will pass, but there are some times it will fail. This could be 3 months down the track when you've forgotten about your existing code base. But when it fails, it means you need to give it some attention because your external dependency has changed somehow or some way that may break your code. And if you ask me, having something that will warn you when it changes silently underneath you will make any developer happy. So if you're ever in this situation where you're struggling with the environment, you're trying to figure out how you can develop, but your environment isn't allowing you to do so, remember that you can use mock servers and fake all the things. If you do use them, keep in mind there are some catches, such as you have to make sure that your mock servers are mocking reality. So you want to make sure you write a good JSON schema definition to compare them and be warned when things do change. But when you do have these in place, you can then start to develop in isolation in a stable environment, decoupled from everything else. You can have a fast dev loop because you're talking to localhost. And last but not least, you can have better testing. You can write all the edge cases you want. You can have integration testing. And you don't have, in order to make sure your code is robust and there'll be minimal regression. So instead of fighting with the environment, remember that you can fake all the things and use mock servers. Thank you.